Oh, oh, I'm recording a video with multiple cameras and lights and everything. Oh yeah, right. Hey guys, my name is Isaac. I'm here for Church Audio Life, and today I want to show you how to make your own mic or XLR cables from home. So first I want to start by thanking John and Lucky Al, who commented on a previous video I made about this, where they gave me really helpful insights and tips how to improve it. But you know, to be fully geeky and fully accurate, I'm not going to show you how to make a microphone cable. I'm not into like a wire making factory. I'm going to show you how to connect an XLR or microphone connector to a microphone cable to create what most people call a microphone cable. Soldering is actually a great skill to have. I actually find it fun and kind of even meditative. And it's really handy because it can save you a bunch of money. You can make your own mic cables, you can create your own adapters, you can make splitters and all kinds of custom things. So for this method I'm going to show you, you're going to need a few things, and there's a few optional things that can make it a bit easier. So first of all, you're going to need a soldering iron with a fairly narrow tip. Now, most of these soldering irons you can get at home don't have that narrow of a tip. It's actually fairly broad. What I actually did was I actually used a file and just filed the end down and filed it to a point, because these ends are actually quite cheap to replace and quite simple to get any kind of Home Depot or any of those kind of stores. So I figured if I ruin it, no big deal, but I just used a file and then coated it with solder and it works like a charm. Of course, you're going to need wire strippers. Little extra snips are nice because the ones on the wire stripper are kind of annoying to work with. You're going to need solder, and a thin rosin core solder is what I recommend. This is actually a Kester. It's a 0.6 millimeter, and it's worked well for me. You have a couple optional things that might be helpful. You can use a ruler if you want to get really precise on your measurements. And then this is a jacket remover. Again, that can be done with the wire stripper, but it's a bit more of a hassle. This is a nice little way to do it. And then these needle nose pliers, sometimes you don't want to grab the wire, or if there's times where you need to get close to it, don't want to burn your fingers, they can come in super handy. Then of course, you're going to need your actual microphone cable. And then of course you need your Neutrik connectors. And I believe these still are the best connectors overall. Now some people talk about other ones being a bit more sturdy, but like I said, I've soldered literally thousands of these and have a very, very low failure rate. And they're so much easier to work with than some of the other ones. The other ones almost feel like antiquated and out of date. You will also need a clamp or some other way of holding on to the connector and the wires. I just have this clamp I already had in my garage. It works out pretty well, but I just actually glued in a little bit of rubber into the inside of it to help reduce or get rid of the scratching and possible cracking of plastic connectors. It's not as convenient. They actually make nice clamps that have rubber already, and you can angle all kinds of nice ways. This is a little bit less convenient, but again, I'm trying to show you how to make cables at home by yourself with what you might already have. But you know, there's a bunch of things you can do to make this job easier for yourself. Sometimes people will say soldering is terrible because they tried it once, but a lot of that is probably because they didn't have a good idea of what the whole technique was about, and also some ways of making it simpler for yourself. So one of those is just how you lay out your desk. So this is fairly typical of how I would lay out a workstation if I were soldering a cable. So I'm right-hand dominant, so I would always put my soldering iron on my right. I would always put my solder on my left, because quite often I use my left hand to grab the solder and right hand to do the soldering. I have the clamp in the middle. It'd be actually nicer to have it a bit more to the center of the table, and this is where those other clamps are nice to have. And then the other tools just in places that are not going to get in the way of the other things as much. And again, I'm right hand dominant, so I put the wire strippers more to that side. I just want to let you know that that's probably a good way to lay things out. When you get into actually doing this, I might move some of this to clear room, and some of that might involve just like moving the cable over to the side, that kind of a thing. Because you want everything to be able to move as easily and as freely as possible without stuff getting in each other's way. And also if you're right hand dominant, you would actually want to usually solder from left to right, almost kind of like when you're writing. So again, you're not going to have stuff get in your way as much as you're soldering. Now, if all of this could be reversed, I think if you were left-handed. It's also really good to make sure you have adequate light. Now, I am using light just for this video, but you can see it's nicely well lit. So I'm going to clear a couple things away just so I can show you this Neutrik connector. So first of all, I just like the way they do their packaging. This is the NC3MMX, as you can see. They got a whole different range. This is the most common, more modern one. It's got, yeah, really well reviewed. They make ones that have all kinds of extra waterproofing and fancy pantsy, but this is the basic one, and you can even buy these in bulk if you're going to do a big project from B&H again, or avshop.ca. There's probably other retailers as well. I'm not affiliated or connected to any of those things yet. This is just where I've learned from my experience. So then, yeah, I'm just going to show you the different components. Now this, of course, is the male. There's also the female equivalent as well. So yeah, there's 4 main parts. The first one is called the boot or the bushing. That's what most people would refer to as a boot. The second is called the chuck. This is basically a strain relief system. The insert, and that's where the actual wires will be soldered onto and will connect into mixing boards or other things. And then the housing. And the housing, of course, is also part of the connection, and it also keeps everything together. Now, the absolute first thing you have to do is put the boot on the wire. I don't know how many times that any of us who've done soldering have forgot to do this. They go on and solder, and then you realize you got to take it all apart again because you forgot to put the boot on. So always, always, always put the boot on first. And eventually, if you're going to do a lot of these, you will eventually make this mistake. Don't say I didn't warn you. Now, this next bit, you notice has a slit in it. So this could be put on after the fact, and that's actually what's recommended in Neutrik thing. But I like to do it now just to get it out of my way. Ready to go. Then what you want to do is get off the outer rubber of this cable, this wire, the outer jackets. This is where I had this optional jacket remover. Interesting little tool. It actually comes with like Cat 5 kind of cables, or because this is actually to punch down Cat 5 cables. But these again are fairly cheap, fairly common. You should be able to find these kind of anywhere. So basically, you got to do is just pinch this deal. Boom, boom, boom. Looks like a little shark. Rah, rah, rah. Anyway, and the amount you want to take off of here, I always kind of estimate and fix it later. So I always take off a little more than I think I would need. The actual amount you need is 18 millimeters when we're said and done. So just kind of estimate roughly a bit more than that. You can trim it later. So then you just pinch this, put the wire in between like that. Use the one that's closer to the right amount, because what you want to do is you want to cut the rubber, but not the actual wires inside. And the other guy too is take and spin this. And that should probably be enough. And then you see there's a bit of a slit there. And sometimes you can just help it by pressing back both ways. Could do it a couple times. Because again, you're trying not to cut the wires underneath. You see the rubber starts to rip a bit. And then using a bit of force, just pull that apart. There we go. Now, if you have any kind of decent cable whatsoever, there should be a pretty good amount of wire around the first 2 cores, because that's actually going to be your ground. And the more it is actually around those 2 wires, the better it's going to do. This one's not bad. There's ones that are more so. This is actually a wire I already had. I didn't actually go and buy this one for this occasion. So I'm not quite sure exactly the quality that it is. So you got to take and undo all this. And try not to get, quite often they use strings or twine or other things to in the manufacturing process. So try to separate that all out. So make sure you have just the copper wire. And then you can, pinch those together and get those good and tight. So always start at the base here and start twisting. And go the whole way down, even though we're going to get rid of some of this, just so it's nice and tight. You should have a nice tight wire like that when you're done. This is where you want to trim off this extra thread here. And so the little trimmer is going to be a lot more handy than the wire stripper. There we go. And sometimes if it's thread, it actually is hard to cut. So you don't necessarily have to worry about it being absolutely perfectly clean. So if you want to be really fussy, you can. That's not going to get in the way of anything when we're said and done. So then for the lengths, again, Neutrik recommends 18 millimeter. Now I normally never measure this, I eyeball it, and 18 millimeter would fall about there. So you take a look at that. That's about the measurement. The way I do this is if you're doing a bunch of projects, you're probably not going to want to take a ruler out each time you do this. So I estimate that it's actually just a bit longer than the edge of my thumbnail to past my finger. If you look at that measurement, 18 is there. So, it's pretty much just a little bit longer than my thumbnail. That'll give you about 18 millimeters. So if you want to do this quickly and you want to use estimates, and again, this, even though there is precise measurements on Neutrik site, I have found that if you're a little bit extra, a little bit less, it's not going to make much difference. If you're way over, it's not going to work well at all. And if you're too short, you make your job harder. So being close is really good, but being exactly precise isn't always 100% necessary. Now, I know some people might argue with me on that, but I've done lists of thousands of these as long as you're within the ballpark. So again, if you estimate just a little more than your thumbnail, you should be G to G. So I'm going to again use that as my estimation and trim that back. And in this case, all three are cut the same length. That's not always the case in every type of cable, but in this case it is. So there we go. That was again there, so about there. And then do all three the same. Then what you need to do is on the positive and negative wires, you want to strip that back. And again, Neutrik's number is 4 millimeters. And now 4 millimeters is going to be about there. So you take a look, edge of that ruler, I'm looking at the red one here. That's 4 millimeters. Another good way to estimate that is if you look at the cups here, what you want to do is you want to be able to fit into the cups almost all the way. And you want that rubber to go right up unto the edge. And that's why they recommend 4 millimeters. So if you can just kind of get that sizing into your brain, again, you should be able to estimate that without having to use a ruler each time. I don't know if there's a better method. If you guys maybe know a better method for getting those exact measurements, let me know. But again, if you're doing a bunch of these, you'll probably want to go fast. So as long as you're estimating that you can get mostly fill that cup, but leaving the rubber at the end will be good. Now, most wire you're going to find for microphones is either 20 gauge or 22 gauge. And I actually don't know in this case, so I'm going to estimate it's probably, it looks to me like 20, because 22 is a bit on the small side. So you look on your strippers for the number 20 there. You stick the wires between there, around 4 millimeters out, and be careful not to get the wrong one there. There we go. And so you got about 4 millimeters. And the spring thing is actually broken out of my strippers, so. There we go. So that's about 4 millimeters in my eyes. Pinch down tightly and then pull. And then you're left with about 4 millimeters. That's a bit on the long side, so I'm going to have to trim that down later. But there we go. Do the same thing for the white. There we go. That's probably closer. If I actually use the measuring tape, actually the red one is basically perfect and the white one's a little shy. Look at that. Now for the actual soldering. The most important thing, I think, part of this is preparing properly, and the biggest part of that's called tinning. So tinning is basically heating up the wire so that it'll absorb solder itself, and doing the same thing with the cups. So you're preparing both the insert and the cables both to be ready to be soldered. So what I usually like to do is take and put the insert into my jack and into my vise. So what I do is I turn it just a little bit. There we go. Just so I can spin it better. And actually, let me just fix that up. I like to have it facing up. I like to have it up at a little bit of an angle so the solder will run backwards. Then I tighten that down. And then what I like to do is I take my wires and get them into a similar place, using kind of the vise to kind of hold it just roughly in place as well. Tinning is essentially, like I said, getting the solder to melt from the heat of the wire. Now, the reason why this is incredibly important is you don't want a cold solder. A cold solder is basically when someone will just kind of drop solder onto cold metal. And that's just, if you see anything online telling you to solder like that, that's just garbage. It doesn't work well. It'll die quickly, quite often. It doesn't even adhere correctly. And so what you want is called a hot solder, because the solder actually is hitting a hot surface. And there's actually a chemical reaction that happens, and there's an absorption that happens where there's a much more deeper bonding of the solder to the metal and two metals together. Another tip when you're soldering is you don't want to have the iron on the wire longer than you have to. Another tip is that the solder itself transfers the heat. So I'm going to tin these wires. Now I had a bit of a solder piece break off on me, and so on the roll, but I'm just going to have that ready. So what I do is have the soldering iron in my right hand, kind of hold it like a cigarette or a pen, you know, and solder in the left. I try to make it as straight as possible, and so it holds nicely. And then what you want to do is put a little bit of solder on the end of the soldering iron and have a little bit of a blob there, and again the heat's going to transfer from there. And then I like to hold it underneath the wire. And sometimes I like to brace my hand on the jack or whatever to give myself a bit more stability. So you see this pinky is there. And then I get that under the wire. That heats up the wire, and then the solder melts onto the wire like that. And so it doesn't always look perfect, but it was the actual heat of the wire melting it. Now a little bit of rubber did melt, because it took me a little extra second, but I was a little shy on that one anyway. And if you have a little bit of that's okay. If you have too much, it'll actually you'll have too much metal sticking out. That's not going to be a good thing. So same thing on the next one. I'll add a touch more there. There we go. And same thing on the ground. Again, this shouldn't have to take forever. So now those are tinned. Can move that out of the way. And then you want to tin the cups. Now what is really important here is that, solder is relatively cheap. So don't be a cheapskate and use not enough solder. So what you should do is, again, I just need to clean this off in between. I have a wet sponge on the soldering iron. There we go. So then again, you want to have a little bit of a blob of solder under your soldering iron. And I'm going to go from, in my case, from left to right. I'm going to hold that underneath the cup, and then the heat of the cup is going to melt the solder. And this is why you need that narrow tip, because it's hard to get a big one under there sometimes. So there we go. And then I almost fill the cup. There's still some solder on there. And same thing on the third one. Put a bit more underneath. There we go. So it's critically important that you have the right wire on the right pin. This is because the whole principle of how an XLR is balanced and how it rejects interference is based on the right wires on the right pins. So 1 is always ground, 2 is always hot, and 3 is always cold, or negative. And in our case, we're going to use red. Red is positive, and white is negative. Sometimes it's black. Since this is a male, pin 1 is this one. So that's going to be the ground. Pin 2 is this one, and pin 3 is this one in the middle. Now, this is the male end, that's why it's that way. On the female, it'll be reversed. But the 3 will always be here because it's always on the bottom. But then on a female, this will be 1 and this will be 2. But in this case, this is the male, so it's 1, 2, and 3. So what you want to do is you want to arrange your wire into the correct shape before you start soldering, and that'll make your job way easier. So you kind of just take it and start bending it into the correct positions there. And try to get it roughly the kind of shape it's going to be here. And now sometimes when you strip the wires pull out a little bit. In this case, I think the white one has done that. So I can, let me just try to shove that back in just a little. It doesn't always work. Or I might just trim a little bit off the end to make it a bit easier. But it should, if it's close, it should all work. But I think I will trim just a little bit off the end, make that just a touch easier for me to work with. And just the slightest little bit. There we go. I also bend these a little touch forward. I find that just easier to work with. Now this takes a bit of practice to get this right, but sometimes you can use the tension of the cable to work with this. And again, you want to go from left to right if you're right-handed, or right to left if you're left-handed, because otherwise you're going to have much more likelihood of burning the cable. So basically what I do is I will hold this in place. Oh yeah, the other wires are getting in the way. There we go. I hold it underneath until it melts the solder of both, and then shove that in. Same thing for the negative. And so you want that rubber to push right up against that jack if you can. And that shouldn't take too long. You shouldn't have to sit there and hold it there for a very long period of time at all. And then same thing with the positive. There we go. And you want to take it off fairly quickly. Now, like I said, since the white one's a little longer, got a little bend in there, but that's okay. Ideally, if you didn't have that, that'd be even better. But that shouldn't cause any problems. The main thing you're looking for here is that there's no exposed metal that's going to touch this ground. There's no grounding that's going to happen between them all, and that all looks really good. Now some people would recommend at this point putting heat shrink around this, but I haven't in the whole time I've done these, and even on Neutrek's site when they look at their recommendations there's no mention of heat shrink. So I think that's maybe an extra step that might be a little helpful, but since these are already coated, this is coated, they have their own chuck, which is a big piece of plastic. That's going to help protect it as well. Heat shrink might be a bit redundant, but if you want to do even above and beyond, you know, feel free to do that. So you would have had to put that on again before you did the soldering, and then cover it and then heat shrink that down. So this is essentially done. Again, you want to do a quick visual inspection that there's the rubber's right up until the end if at all possible. There's no chance of these touching each other. Everything is good and secure. You can do a quick little pull test to make sure they're on there well and secure, which these are. And then I just take that out of the jack. And of course, if you don't wait till it's not going to burn your fingers, you can bend that a little bit. Make sure it's nice and straight. Then it's as simple as lining up this chuck to these little grooves. And then you can see that slides into that groove. You kind of can even pinch that a little bit. And then you take the housing and slide it on top of that. Let me turn that around actually for you. There we go. So that's facing up. You see the pins are that way. Housing with the Neutrek symbol facing up. There we go. That just slides together. Let me show you from this angle. It just slides in. And it only slides in a certain way, so you want to make sure that you got it lined up correctly. I'll show you from the back here. Kind of like this, and there we go. Sliding in. And you see how it's touching right to the front of that thing. There we go. Then you take the boot, slide it forward, and then screw it together. You want to make sure that is good and tight. Probably do a little more. There we go. If you had a tester, once you got the cable fully done, you could do a bunch of testing. But then to do the other side, you do this whole process just in reverse. And the female connector is much the same. Everything works on the same principles. You put things together in the same orders. The insert looks a little different. But other than that, the whole thing is basically the same. And again, watch out for the cables. You don't want to reverse the two cables. You want the 1 and 2. So always, every single time before you solder, even if you think you know which side it should be on, always take another quick double check that you know which one is pin 1 and which one is pin 2. Pin 3 is always going to be the same, like I said. So there you go. I hope that helped. XLR cables can be used, of course, for microphones. That's their main use, but you can also use them for monitors, for line level sources, for just almost anything in audio, pro or consumer. And being able to make your own could save you just a ton of cash, and it could also help you make your own connections. And so I hope this is going to be helpful. I hope you'll go out and try this. If you're watching this video, you probably will. Okay, well, take care. God bless.